So as of now, we have seen two different types of data which we can feed into the neural network. That is a pre-necessary or preliminary step which we follow in order to convert these different types of data into numerical form before feeding it into the neural network. Now it's time to deal with other type of data, that is textual data. So when it comes to any NLP task, either maybe building of a chatbot, speech recognition, speech translation, document summarization, etc. Maybe with any kind of NLP task, we are generally ending up with textual data. So can we feed or can we directly feed this textual data into the neural network? Is it possible? No, again, because we have to convert this textual data back again into numerical form before feeding it into the neural network. So let's see how we can do that. So we have two different approaches to do that. One, the highly sophisticated and most popular technique, that is using word embeddings. So what are word embeddings? So word embeddings are pre-built models or pre-built tools which we can leverage in order to convert the rawly available textual data into numerical form. So it's just not convert the whole textual data into numerical form, but it also tries to convert the hidden semantics, syntaxes, also a relationship between each and every word before converting it to the numerical form. So it has its own abstract way of converting the textual data into numerical form. So we have two different kind of word embeddings available in the market today. So that are they are word2vec and glow. So these two are different types of word embeddings. Both perform very well when it comes to task of converting the textual data into numerical form. So we use this in order to convert any kind of textual data into a matrix or a vector form. The output of these two word embeddings would be a embedding or a vector represented in the numerical form. Suppose if we have a data, say with 10 columns, we have only all the 9 columns already in the numerical form, but we have only one column available with a textual form. So one of such thing would be like a class registry, right? A class registry or a class registry about different subject marks. So we have marks allocated in different columns. At the end, we are filling up the student details. Then there is a column called gender for that. So if it is a gender, then it would be generally male or female, right? So in order to convert the textual data or the column, that particular textual column into numerical data, we can approach another kind of technique called as one-hot encoding. So let's just dissect this into three different parts: one, hot, and encoding. So one hot is nothing but we are picking up a textual form or taking up a textual data, and we are allocating some number, one hot number, to that particular text, or in other ways we are encoding a particular text into a numerical form. Since we have only two categories here, I have converted this male and female into 1 and 0. So throughout the column there will be either 1 or 0 replaced by male and female, right? So this male and female will no longer be available in that column. They are replaced into 1 and 0s. Thus we are converted this textual form into numerical form. What if we have multi-class or multiple textual data? Say suppose if it is a column where it says about the grade, so we have different kinds of grade, right? We have A plus, A, B plus, B, C, C plus, etc. So in that case, we can't just name it as 1 and 0, right? We can leverage other numbers as well. So we can just name A plus as 1, A as 2, B plus as 3, B as 4, etc. So we can continue that in a particular fashion. But the whole idea is whenever we encounter A plus as a grade, we will be seeing 1 in that place. We don't see any other number, right? So we are just allocating one hot or one particular code to that particular text form. So this is one of the naive way of converting the textual data into numerical form as well. So this is about converting the textual data into numerical form by leveraging word embeddings and one-hot encoding. So we can leverage any of the thing depending upon the task which we are dealing with. So now we have covered three different types of data, that is speech, images and text. Suppose if we have numerical data or numerical features already available with us, then there is no need of this preliminary text of converting it to a numerical form, right? That makes sense, right? If we are already available with numerical features, then it's a very proactively step. We can say that we can directly feed it into the neural network. So, where can we avail these numerical data? Suppose if it is a data covering about the transaction logs of a credit card, then definitely it will be in the numerical form, right? It will be available in the numerical feature as well. So, these are all the type of data which we can feed it into the neural network. So on a ground note or on a summary, we can say that we can deal with any kind of data irrespective of its kind or irrespective of its domain. Only thing that before actually feeding any kind of data into the neural network, we have to follow a preliminary step of converting that particular data into a respective numerical data. We have to choose an appropriate method as well to convert the individual data set or a different kind of data set into numerical form. We can't just go with the approach of word embeddings for the images, right? We have to go with the approach of pixels, right? If it is a speech, we can't go with the approach of pixels, right? We have other ways to do that. We have to choose an appropriate method to convert individual different kind of data into numerical form. So thus we can on a high note, we can say we can deal with any kind of data in the neural network, and we can in order to do that, we have to follow a one preliminary step to convert the data into numerical form. So now that we have seen a different kind of inputs or what is the format of the input for the neural network, in the next session we will arrive or we will see what will be the output for a neural network. So what exactly the format will be for the output of a neural network.